in today's car is such a commonplace thing that few drivers are without this popular source of entertainment. And there's a wide variety of equipment to choose from: AM, AM/FM, and multiplex stereo radios, tape players, and even a recorder. But as you know, it's not all music and the news. Sometimes it's no reception, weak reception, or noise. And then the customer usually wants it fixed right now. Generally speaking, radio troubleshooting in the service department boils down to finding whether the problem is inside or outside the set. In any case, don't be too anxious to pull out a set for repair until you've checked out the rest of the system, including power feed, speaker, and antenna. We'll cover the things you can check without removing the set farther on in our story. Right now, let's talk about radio transmission and reception characteristics to see how they affect radio operation. You'll find that a good understanding of these conditions will help you sort out reception troubles originating in the set from those which are caused by the transmitted signal. We're concerned with two basic types of radio broadcasting: AM, or amplitude modulation, in which the transmitted sound causes the amplitude or height of the radio waves to vary, and FM, or frequency modulation, in which the frequency of the waves is varied. The frequency of the AM broadcast wave is relatively low, and like a sound wave, it curves or bends around obstructions. The ionosphere layer of the atmosphere bends these low-frequency waves back to Earth, so AM programs can be picked up at fairly long distances. Because of this wave-bending characteristic, AM stations which broadcast on the same frequency are located as far apart as possible to minimize station mixing interference. In contrast to AM transmission, FM waves are broadcast at very high frequencies and reflect like light waves. Since FM waves do not tend to bend, they penetrate the ionosphere, and as a result, only the waves which can travel to the receiver in a relatively straight line are effective. This transmission characteristic limits good reception of FM broadcasts to an average of about 25 miles under average terrain and station power conditions. As a result, distant station mixing is seldom a problem. Now, all radio waves pick up electrical disturbances in transmission. Since these disturbances mainly affect the wave amplitude, they remain a part of the AM sound, but do not interfere with the frequency variations which carry the FM sound. Because AM sound is based on wave amplitude, it's not possible to clip off the electrical noise portions of the wave without cutting off the sound. As a result, AM reception can be disrupted by lightning, power lines, neon signs, and other similar sources of electrical disturbance. On the other hand, because FM transmission is based on frequency variation, the sound travels within the basic broadcast wave. This allows atmospheric or other similar electrical noises to be clipped off, leaving reception relatively clear. However, if FM signal strength is weak, the broadcast wave height will drop below the effective cutoff level, and noise can then pass through with the diminished wave. Now, let's look at some of the conditions which can affect FM reception quality. Unlike the home FM set, the car radio is directly exposed to strong local interference from the ignition system and other electrical devices in the car or in other nearby cars. This interference is normally minimized by the cutoff action of the set and radio suppression items. In addition, the home set remains in a fixed position, so it's not exposed to changing interference conditions, signal weakening, and higher noise levels which occur when the car is in motion. Since high-frequency waves reflect, FM reception is often possible under bridges and overpasses where AM radio may fade out completely. However, like light waves, FM can be reflected or blocked by tall buildings and similar structures which intercept direct line transmission. This wave-blocking condition causes shadows or dead spots in the FM signal, which produce a momentary interruption flutter in the sound as the car passes the obstruction. In comparison, when FM waves reflect from obstructions, the transmitted signal is disrupted, causing what we call multipath interference. Wave disruption occurs because the reflected and the direct signals can both reach the receiving antenna at the same time, causing an effect like this.
During July, the job was great.
Another condition which can result from FM signal interruption is station capture, or swapping, where we get a momentary station change without touching the tuning controls.
At the Eagles, and before that, all it was love.
Station capture can occur when two strong stations are close together on the FM dial and something interrupts the original signal. The radio's automatic frequency control system then pulls in the second station.
All it was love.
FM automatic frequency control keeps the radio from drifting off the station setting. Automatic control is needed because the receiver is exposed to wide variations of operating voltage and temperature, which could otherwise upset the FM tuning balance. Now we're ready to consider the things you can check in the car without removing the radio. So we'll begin with a procedure for troubleshooting a dead or inoperative set. Here, we use the process of elimination to isolate the trouble source. The whole thing can be made simple by thinking of the radio as a central unit which has a power input circuit, a sound output or speaker circuit, and a signal input or antenna circuit. Begin your check by listening for a thump in the speaker as the switch knob is turned on and off. If no thump is heard, the cause can be an open or short circuit in the power input line, a bad speaker, or trouble in the radio. If the fuse is okay, check the power input harness for an open circuit and make sure that power reaches the set. A blown fuse could mean a possible short in the radio harness, in other connected circuits, or in the radio set itself. To check out the speaker, simply use a known good speaker as a substitute. In any case, do not try to operate the radio with the speaker disconnected, because transistor damage in the set may result. Incidentally, don't overlook the possibility of a loose or missing shorting plug or trouble in the fader control and speaker wiring. Where the installation has a remote stereo cassette recorder, remember that the radio is mute when the recorder selector control is on microphone record. To check the radio, set the selector on any other position and unplug the microphone. You can use a shorting plug to find trouble in the recorder, in the connecting cable, or in the radio. The plug is a standard part which is installed in the cable receptacle of radios not connected to a remote cassette recorder. Install the shorting plug in the recorder end of the connecting cable. If sound is heard in the speaker, the trouble is in the player. However, no sound can mean trouble in the cable, speaker, or radio. If you get radio sound when the shorting plug is in the connector at the radio, the cable is faulty. Now, let's continue our test for an inoperative set. If the speaker only thumps as you switch the set on and off, but there is no other sound, it usually means that the set is working but no signal is coming through. Here we assume that the remote cassette recorder and cable are okay, and that the shorting plug is securely in place on other stereo radios. To check for no signal input, try a substitute antenna. If the set then plays, you'll know that the trouble is somewhere in the car's antenna or its lead-in cable. Here, as in the power input and speaker tests, no response points to trouble in the radio. Next, we'll look at some of the causes of weak reception. And since radio reception begins at the antenna, we check it out as we did with an inoperative set by plugging in a substitute unit. If reception improves, it could mean that the car antenna is faulty. If the substitute antenna does not improve reception, then try adjusting the antenna trimmer in the radio. In any case, the car antenna should be checked and the trimmer adjusted before the radio is blamed for weak reception. Antenna trimmer adjustment is simple. First, on AM/FM radios, set the selector for AM reception. If a power antenna is installed, raise it to approximately 31 inches. Next, you manually tune to a weak AM station between 14 and 1600 on the dial. Then, turn the tone control fully clockwise and set the volume control at a comfortable listening level. Remove the tuning knob and adjust the antenna trimmer screw back and forth until you reach the peak output position. The process sounds like this. The trimmer screw on other radios is located on the radio chassis near the antenna plug-in socket or behind the door on tape player models. After the trimmer is adjusted, make sure that the push buttons are set properly. It is not unusual to find that some customers do not know how to set the buttons correctly, so Demonstrate this procedure if necessary. If there is a complaint of occasional poor reception with push-button tuning, explain that it may be necessary to fine-tune some stations with the knob. Now, let's talk about radio noise conditions, which can be corrected without removing the set. These noises are most noticeable on AM radio, so make your tests on this setting. First, there's a buzzing ignition noise which changes with engine speed, like this.
Earlier, however, to meet with Communist Party Chief Leonid Brezhnev has given rise to speculation his mission to find...
This noise can enter the radio through the power input circuit or antenna if the suppression capacitor on the ignition coil is defective or has loose connections. Defective, loose, or unsuppressed wire core spark plug cables will also contribute to ignition noise. Also, make sure that all ground straps are securely tightened. Another noise which can sound off through the radio is a whining sound in the background. If the pitch changes with engine speed, like this, the noise can be caused by a defective capacitor or diode in the alternator, or by a fault in the radio itself. When checking, make sure that the alternator gauge wire is well separated from the radio, and that the chassis is securely mounted, because either condition can cause noise. Radio noise can also be caused by the voltage limiter mounted on the back of the instrument cluster. If the limiter is faulty, or its suppression capacitor is loose or missing, you can get a crackling static noise. Now, for a wrap-up, let's talk briefly about distortion sound complaints. Here, the radio and speaker system are possible sources. If a substitute speaker clears up the distortion, the problem is somewhere in the speaker system. Don't forget that a loose speaker mounting, a bad fader control, or a defective crossover unit can also cause distortion. Sound distortion from the tape player can be caused by dirt or oxide residue on the capstan and playback head. This accumulation can be cleaned off with a cotton swab moistened with alcohol and should be removed after every 100 hours of operation. Obviously, you'll encounter other radio and tape player problems which we're not able to cover here. But as usual, you'll find more on what you need to know in your reference books and the service manuals. Now, as a parting word on troubleshooting radios and sound systems, we repeat. Analyze the trouble. Check the power input, check the sound output, and check the signal input before you remove the set. And that's our story for this time. Thank you for your kind attention, and goodbye for now.